Hello and welcome to episode 644 of the People Behind the Science podcast. To celebrate Black History Month this February, listeners, we are thrilled to be highlighting the work and the stories of some excellent Black scientists. In this episode, we are revisiting our conversation with Dr. Angelique Johnson, originally published on July 4th of 2016. Listeners, Angelique is an engineer and an entrepreneur. She co-founded a company that produces implantable electronics to treat neurological disorders such as hearing loss. And Angelique shared wonderful stories about her life, her career, and her work in our interview. So get ready to get inspired in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. Today, I am excited to introduce you all to Dr. Angelique Johnson. So, Angelique, thank you so much for joining us on the show today. How's everything going?
Going great. Yeah, awesome.
Fantastic. Well, we are delighted to meet you, delighted to hear more about your science, but I want to introduce you to our listeners first. So, listeners, Angelique is founder and CEO of the startup company MEMStim, which is dedicated to reducing the cost of cochlear implants to treat hearing loss. She's also adjunct faculty in electrical and computer engineering at the University of Louisville. Angelique received her undergraduate training in computer engineering and mathematics from the University of Maryland, Baltimore County. She completed her master's in engineering and PhD in electrical engineering at the University of Michigan, and she has received many awards and honors for her impressive work, including the Pryor-Hale Award for Best Business at the Michigan Business Challenge, as well as funding from the NSF Innovation Corps program, and recently an NIH Phase 1 and Phase 2 SBIR grant. So, Angelique, many accomplishments for your work, but we are excited to get to know both your science and you today. We want to hear both about you and your work. So let's start by talking about what you like to do with your time when you're not very busy doing science.
I'm a big kind of people person. I love interesting conversations. So it can be something as simple as a great conversation over coffee with a friend. I also like dancing a lot. Because salsa dance. I love running. I've run a few marathons. So usually in the morning time, I'm out running somewhere. Other than that, just relaxing, listening to music, I guess.
Fantastic. What kind of music do you like?
I like all kinds of music. I was listening to NPR this morning, and they were doing something on Simon and Garfunkel, and I was like, man, I haven't listened to that album in a while. I should listen to that. But I like hip hop. I like R&B. I listen to a few country songs. My mom used to listen to country music a little bit when we were younger, and classical music. So just all kinds of genres. Just depends on the mood.
I love it. Well, Angelique, it sounds like you lead quite a busy life outside of science between running, dancing, this social life you have. I think it's fantastic to have a great balance of different things you like to do with your time. So you're not always just living in the lab.
Oh, yeah.
But I do want to talk about your life in the lab next, Angelique. So can you tell us, what is the high level description you give people when they ask you, what do you do?
Okay, so I usually tell people that I create implantable electronics for restoring nerve loss or neural function that's damaged. That's kind of the high-level description, but then a little bit lower than that is I work on making cochlear implants that restore hearing loss to individuals, or some individuals never had hearing to begin with, and it provides speech recognition. And going a little bit deeper than that, I work on microfabricated arrays, bundles of wires that you implant inside the body that stimulate inside the ear and induces sounds.
Very cool. I like how you have these different levels of description of what you do. I think that always helps. You can always gauge people's interest at level 1 and then progress through the other levels.
Yeah. Retreat. Don't say anymore. They're not interested.
Right. Back up slowly.
Yeah.
Well, Angelique, wonderful to hear more about your work, and I'm excited to chat more about it as we go through our conversation today. But I want to talk a little bit first about what motivates you. I think there's so much to get done in a day. As a scientist, I think you have lots of work to do, always piling up on your plate. What keeps you going? Do you have a particular motivational quote or a saying that you use in your life?
I do have actually a motivational quote that I use a lot. To give you some background reference, I feel like what motivates me usually is, and I hate to say it's terrible, is I need some sort of crisis. And I think there's always, every day you wake up, there's a motivational crisis that could come in, either a technology crisis or business crisis. And I use that term loosely. It's not a real crisis, but it's something that motivates me to say, okay, this has to be solved today. And so one of my favorite motivational quotes is actually from the Bible. It's Habakkuk 2, chapter 2, verse 2-3. And it goes something like, when he answered, the Lord told me, write out the revelation, engrave it clearly on the tablets, so that a courier may run with it. For the revelation pertains to an appointed time. It speaks truthfully about the end. Though it delays, wait for it, because it surely won't be late. Something like that. I don't remember the full one.
Sure.
But basically, in that chapter in the Bible, this prophet is, like, prior to this verse, it's just, like, freaking out and, like, everything's going wrong. And he's trying to live his life right, but everybody else is living it wrong. And they're getting all these wonderful things. And everything he's praying for is not coming through. And, I mean, I guess you could look at it as kind of a religious thing, but it's also just, like, a life thing. Like, life around him is just not going as he thought. His career, which is being a prophet, is not working out too well.
Mm-hmm.
And so for me, every time, like, science is unpredictable. There's always, you think it's going to work and it doesn't work. And you're like, okay, should I just abandon this and move on to the next interesting question? And so whenever I come against like a roadblock, I remember that, okay, even though things look crazy and hectic now, don't worry. You had this vision, this well thought out theory of how this should work, and it is going to come through. You are going to find the correct solution. It might delay, but it's not going to be late. So it's kind of what I use to motivate me.
I love that. And I love that phrase that you snuck in there. Science is unpredictable. I think you're absolutely right. So many crazy things can happen in science that you weren't expecting. So
oh, yeah.
I think that's a great motivational quote. And I know myself, I do tend to be most productive when I'm in crisis mode. So I think that's a good motivator.
Yeah.
So now, Angelique, tell us a little bit about the people who've motivated you or inspired you. I love hearing about the role models and inspirational figures that scientists have looked up to in their careers.
Oh, yeah. So my first motivators were my parents. They were both in science and technology. My father was a chemical engineer and an environmental engineer. And my mother, she was a mathematician. She also did computer programming. Both my parents are in their 70s. Hope I'm getting this right. In their 70s. So as you can imagine, my mom was doing coding when the rest of the world wasn't quite doing coding just yet. And so when they raised us to be very science and technology focused. So that was very inspirational as far as career path. And then I had older siblings. I'm one of 11 children, and I'm number 9, so I have a lot of older siblings.
Oh, wow.
Yeah. A lot of them went into science and engineering. So I've had older siblings that kind of blaze the trail and let me know, like, what to do, what not to do. I could call them if I was in college and I had an issue with a course. I had somebody I could call and be like, okay, I'm stuck. I need some help.
Right.
And I'm also inspired by people that have, like, overcome failures. And so sometimes it could be as simple as just, I wake up in the morning, I'm like, okay, I'm going through something really rough with this startup, and you just get motivated. And I'll just, like, maybe turn to a TED Talk or just Google, like, okay, entrepreneur or something like that. And I think in some ways, those people have also become my role models. And of course, my thesis advisor and people along the way.
Absolutely. I think sometimes looking to entrepreneurs as role models, it's like inspiring, but then also makes you feel better because it could be worse. Like,
oh, yeah.
Some people have really devastating stories. Yeah. Well, wonderful to hear about some of these people who've had a big impact on you in your life, Angelique. And now you mentioned you grew up in a relatively scientific family. Can you tell us what was the first point, or do you have a memory that really comes to mind about when you first started thinking about science as a career, or started getting interested in it?
I really can't remember when I first started thinking about science as a career. It seems like it was always there and I was going to do it. Mm-hmm. But I do know that the time at which I first felt confident that I could do science as a career was I had gone to math camp, of all things, to go to. It was worse than band camp right. As far as the stigmas attached to it. But I promise you, it was fun. I went several summers and I had a blast. It was at Southwest Texas State University. And they were teaching us math, but it wasn't like algebra and even calculus. It was math theory and things that, of course, that you usually don't take until you're maybe in your senior year of college and you're a math major. But it was a lot of fun as well, but it's challenging. And so I remember, like, coming back home from that math camp and realizing I approached something that's really challenging. Like, this was high level stuff, and I actually did well in it. And I felt like a sense of relief, like, okay, I can do this whole science and technology thing. If I can come through that, I can come through anything. So I guess that was probably my first moment of having confidence that I could do this.
Definitely. And I think building that confidence is key. And I think a lot of people are intimidated by math in particular.
Oh, yeah.
And you said that you went to this camp, and definitely I'm sure your family instilled this as well, kind of making math fun and seeing it more as a challenge or a puzzle than a barrier.
Oh, yeah, definitely. The other thing is people always say, I was going to be an engineer, but I didn't like math. And the funny thing is, I was a math major. Of course, I majored in all these engineering disciplines. Mm-hmm. And while I probably use math every day in some behind the program that I'm looking at way, just like if you think about everybody on Facebook is using math in some way, right? But they're not doing it.
Right.
I know very few engineers nowadays that once you get into your career, that you're using math like in any concrete, like I'm sitting down doing equations. That's not the case at all. So I always think it's a shame that people walk away from engineering because of this whole issue of like, I wasn't good at math. So I'm like, that's such a small part of what you would ever end up doing in your day-to-day.
Right. And I think we have so many tools to help us now that you're not dependent on coming up with those equations yourself.
Definitely.
So Angelique, tell us a little bit now how you went from being this curious student, becoming interested in math and engineering. What are some of these key steps along your path that really helped you get to where you are today as an entrepreneur and faculty?
So prior to college, the things that helped out a lot were those things like doing math camp in the summertime and getting used to being on your own and challenging your brain, and also getting letters of recommendation. I always start there, and it sounds trivial, but because I always hope that somewhere there's somebody young listening to this, mm-hmm. that those things really do matter. And then going into college, I was part of a scholarship program, the Meyerhoff Scholarship Program at University of Maryland, Baltimore County. And the whole purpose of that scholarship program was to get more minorities into PhD programs and get them to achieve their PhDs in science and technology. And so that program really helped train me for what research was going to be like. And I took internships every summer at different MIT and Caltech and all these different universities and worked with all these different labs and understanding how to do research and also whether I liked it or not. And then after college at BC, I went on to do my PhD program at University of Michigan and got a master's along the way. And when I started, I knew I wanted to do something with computers and medicine because I was a computer engineer in undergrad, but I didn't want to make smaller, faster computers. I didn't have any interest in that. I was fascinated by medicine, but I didn't want to be a doctor because I didn't want the gore and all that. Patient care was not my thing. But yeah, so I went to the University of Michigan because they had a good microelectromechanical systems program that combined biology with electronics. And I worked with Dr. Kenzel Wise in his lab, and he presented me some ideas for projects. I was going to came knowing I wanted to work on hearing. And I was like, okay, this cochlear implant project seems really great. A, because it was really interesting, and then B, because I saw that it was something I could fantasize about making and actually somebody using. Mm-hmm. And that really is important to me. I want to make technology that people actually will use in my lifetime. Right. And not just my lifetime. I want to make technology people will use in the next 5 years. That would be great, right? That's always the dream.
That's awesome.
So that project worked out great for that. And he gave me lots of freedom to structure it how I wanted to. And he was an expert and just wonderful man in the area. So that really helped me to figure out, okay, I not only want to do research in this, I actually want to spin out a product. We have some industrial engagement with different implant companies. And then we did the NSF program that helped us further solidify the idea that, okay, a startup could be successful in this area of microfabricated electrode arrays. And I guess now here I am today.
Well, that sounds wonderful. It sounds like you've had a great experience throughout your career going through these different programs with all these mentors along the way. I'm curious, a lot of people are interested in branching off and doing a startup company, but they don't really know how to approach it. I think a lot of our scientific training doesn't necessarily gear us towards that path. So can you tell us a little bit about some of the difficulties you had starting on that road, or what the experience was like when you took that leap?
There's lots of challenges to it, but probably the most difficult challenge is that I didn't realize when I was starting, but now I fully understand it, is that engineers and scientists that are in academia think one way, and engineers and scientists that are in industry think another way. And just starting out, thinking about the idea for my company, I paired up with an MBA team of students, and they kept trying to force, like, it's all about the money, revenue, that's all that matters. Mm-hmm. Whatever your technology or science is, that's just a means to an end. We don't really care about that too much.
It's all about the finances, yeah.
And I was like, no, but it is all about the technology. What are you talking about? Like, you don't have money if you don't have this wonderful thing, this creation I've made. And I think I had to struggle, and I think a lot of scientists that come out of academia and try and do a startup have to struggle with, okay, letting go of the love of your technology because you love it, and moving into how do I make this technology a product that can actually get into human hands, and how do I make it profitable? And it took me probably a few months to understand intellectually that concept and to do well in business plan competitions and all this other stuff. But it took me a few years to change my mode of operation from investigating science for science sake and maybe some future goal to product development on something that's highly innovative. And you're kind of in between the industrial space and the academic space as an entrepreneur with an idea that's spun out of a university. I think that's the hardest thing, just trying to remind yourself that it doesn't have to be perfect to be sellable. But at the same time, yes, I wanted to make profit off of this, but I do want it to revolutionize the industry and trying to find a sweet spot between those two areas.
Absolutely. And I think, having that flexibility in your mindset, being able to see both sides of the coin there, I think is really helpful too. So now tell us a little bit about one of these projects you have going on right now, either within the university or within this company, that you are just so excited about in a little bit more detail.
So my company, we're making microfabricated Cochlear electrode arrays, and we're choosing to focus on is how to get microfabricated arrays to a point where they can pass the FDA for long-term use. We want something that's going to have to survive greater than 30 years in the body and all the challenges associated with that. Mm-hmm. And then at the same time, because I am a startup, not just thinking about how do I make this wonderful piece of technology that can survive in the body 30 years and function, has high performing, and all these other things, but I'm also thinking, how do I manufacture this in a way that can be commercialized versus just somebody making it in a lab and blowing on it just to get one device to work just right. And how do I make scores of these things that you can ship to customers anywhere in the world? So both of those things are very challenging because they have to go hand in hand. Someone might approach me and say, Angelique or Dr. Johnson, like, here's this wonderful new technology that's just going to make your arrays perform beautifully. And I'm like, oh, this is really great. Like, yeah, of course, I'd love to have that. And then I look at it and I'm like, but I can't manufacture that. There's no infrastructure to manufacture using that technology. And maybe when it gets further along, we could incorporate it. But it's just making those decisions and trying to figure those things out. But I'm specifically focusing on microfabricated Cochlear electrode arrays at the moment and all the challenges around that.
Definitely. And I know I myself am guilty of assuming these days that everything is automated. There's a system to produce all these, but that's not correct necessarily in cochlear implants. Like you said, some of these are still being made by hand, or aspects of them are still literally handmade by one person in a lab, which it kind of blows my mind.
Yeah, a lot of medical devices still have significant components that are assembled by hand. And I guess they're called semi-automated because they have with the cochlear implant, right, or even any kind of nerve stimulator lead. And neurostimulator is just any device, any implantable electronic that's in the body that either stimulates nerves or neurons. And that could be pacemakers, deep brain stimulators put in the brain for Parkinson's disease, could be spinal cord stimulators, which are implanted in the spine for chronic pain. All those things have some pulse generator and then some bundle of wires with ball tips that they call an electrode array. And that electrode array is in large part assembled by hand. So it's people taking these wires that are like 25 microns in diameter in some cases. So 25 microns, for those that aren't familiar with this space, is a quarter the diameter of your strand of human hair.
It's tiny.
Hair is like 100 microns in diameter, roughly. Yeah. So it's really tiny, and they're welding it under a microscope. And then after they're done welding the electrode balls onto these really tall, tiny wires, micro wires, then they put in and do injection molding. So injection molding is the automated part of it. But the tedious part and the most critical part is still done by hand. And so what we want to do is fully automate everything. We want to, instead of welding under a microscope balls to very fine wires, we want to be able to just draw in a CAD program those wires and then take it down to a machine, a series of machines that will then take that design specification and build it up in an automated way versus using any sort of welding under a microscope for every individual device. And that's not only going to decrease the cost significantly, right? We're talking about more than a 10x reduction in cost that could occur because of that process. It also allows you to add materials and features that you cannot manipulate by hand, even if you are using tweezers under a microscope. Some of our material layers are very thin, maybe less than 0.5 microns or even smaller. Again, thinking about the 100 micron diameter of a human strand of hair, you can imagine that's really thin, and you can't manipulate that with your hand. And then also channels that we could put in there. There's a whole host of things you can do once you're using machines to make something versus human hands.
Well, Angelique, I think this is so cool and really innovative in terms of this process that you're doing to build these cochlear implants. So now, can you tell us, you mentioned you're in the process of potentially getting FDA approval to move this then directly into humans. How far away do you think you are?
We're very, very early in that process. So I guess the way I see it is first step is characterizing your devices on the benchtop setting, right? In vitro, you're not putting them in the body. You're just trying to make sure that they meet all the specs that would be necessary if you were putting in the body. So mechanical specs for our devices, can you pull on them? Can you tug on them without failure? Mm-hmm. Can they pass bend tests and all these other mechanical tests? And there's also electrical tests. There's current stimulation that's going through these devices. Can they handle it? Can they deliver the appropriate amount without being damaging to the nerves and the neurons that they're interfacing with? So it's all this benchtop. That's what we've been working on for the past year and a half, and we'll continue working on that for the next year. And then in addition to benchtop, there are the first stage of pre-clinical work would be putting the devices in human cadavers and trying to assess, okay, now does it do any damage to the body? How does it go into the right spaces? And assessing that in a human model as close as you can get. And then after all those things have been verified and you're sure that you're not going to cause any damage to anybody's body and that your device will actually function correctly in the body and not just for a little bit of time, but for the intended time of use, then we can move into clinical trials. And for us, since we make just the electrode array, we'll have to combine a pulse generator with that before any sort of clinical trials are done. So we're looking at hopefully 2 to 3 years kind of beginning to start that early phase of clinical trials, getting our devices ready for that phase.
Well, that is really exciting, Angelique. And I know we started to touch on some of the challenges of the work that you do, and particularly of entrepreneurship. And I think science in general is riddled with challenges. So is there a particular story you want to share with us today about maybe a failure or a challenge or a struggle that you had and the steps you took to get through it?
Yeah, every day is a challenge. To be honest, they all start blending together. Challenges like this hum that just goes through your daily day, like a challenge, I'm here, don't forget about me. But maybe one I can remember, as a graduate student, I was working on this technology, and I was trying to get my arrays so that they could go into, we're using guinea pig animal models at that point, and my arrays, electrically, they worked, they were functioning great. But we could never get them to actually go inside the cochlea of the guinea pig and still be functional. They always crumbled or it just wouldn't go in. And I remember trying all these things and it wasn't working to get the technology where it needed to be. And I got really down about that. And I was like, oh, this just isn't going to work out. So then my advisor, I actually didn't have I've been submitting at this conference. So my advisor was like, oh, if you can go to this conference, just go. That's fine. You're not submitting anything, which is rare. Usually you submit something and you're going, but he's like, you can go. And he invited our whole group to go. So we went, and I remember sitting in the conference and I was looking at one of the oral presentations, and it's just something that the person said in an oral presentation gave me this great idea for how to totally redo my array and make it start working. And I went back to the lab after the conference was over, and it took me a few months, and I implemented this idea and it started working. And I still remember to this day that I think if I hadn't gone to that conference, I never would have thought of this feature to add to my array that totally changed the trajectory of how successful I was with what I was trying to do at the moment. And I keep that in mind because whenever I'm stuck on something technology-wise, I always step back and say, okay, I'm just going to look at other people's random stuff, whether it's related or not related, because the idea I actually got wasn't even related to microelectrode arrays. It has nothing to do with that. But just to clear my mind and then hopefully get inspired to think of something new.
Well, I love this story, Angelique. I think that is really key, being able to step away from your work for a little while and get exposed to new ideas. And I think that's one of the things I love most about conferences is going and just finding the most unrelated talk I can find to my field. But it usually makes me start thinking about it differently, right? So you get some great ideas.
Yeah.
Well, wonderful to hear about this challenge and how you worked your way through it. But we don't just want to talk about the downtimes. Angelique, can you share with us one of your success stories? And this can be a big moment in your scientific career, or even just a small victory along the way that meant a lot.
My biggest success moment so far, I'm just starting my career, I guess. But my biggest success was when I got my NIH Phase 1 grant, because I had already applied once for it and I didn't get it. And I guess I was so new to this that I felt I didn't get accepted at this grant. There's no point in applying again. I had other colleagues that are applying too. And I talked to other people and oh, those are really hard to get. And I was okay, I'm not even going to apply for it again. And I ran into actually an old mentor of mine. She's phenomenal in this field. And she was telling me about, I applied and I didn't get it. And we applied again the second time. We didn't get it. And then we applied the third time. We did get it. And I was like, okay, well, she's so great and amazing and she can apply again. I can apply again. So I applied again, but I really didn't have much hope that I was going to get it. Not only because I didn't get it the first time, but because I'm thinking a little bit differently about commercialization, I think, than other people that spin out of universities do. Innovation is a natural part of any product development, but I choose to focus on what are the key steps I need to do in order to commercialize the technology and turn it into a product versus in order to get like another publication. I don't think in those terms. So I was like, listen, I'm just going to write it again. I'm just going to write the way I want to write it against the advice of people that are reviewing it and saying, okay, Angelique, it's not innovative enough. And I was like, well, it looks pretty innovative to me. I mean, nobody's done it before and nobody's got to work. So like, it seems innovative. Mm-hmm. And then when I got that phase one, that was like a huge, I think, success to me because it really, to me, felt like validation that, okay, I was on the right path and I was thinking about the problem the right way and other people saw it. And then more importantly than that, which is great, but the reality is more importantly, I had some funding to actually start pursuing my startup full time. And up to that point, I had been like a little bit in the startup and a little bit in the academic world and trying to figure out like which one I was going to be able to move into. And so that was like a big success for me. And since then, I've raised more money. And I guess like in the next few months, I will raise about $2.5 million or something.
Oh, wow.
Close to $3 million just in grants and awards and different competitions, things like that all combined. But in that moment before I got that phase one, even though I had done some other grants, I felt like, okay, this is not going to work out. But when I got it, I felt like, okay, maybe I could do this. Maybe I'm not in the bad train after all.
Well, congratulations on this success. It sounds like exactly one of those stories that starts as a failure, but then with persistence, you're able to turn it around into a success. So do you remember where you were and what the circumstances were when you got that acceptance notification?
I know I was in my office, and at that time I was a faculty term researcher at University of Louisville. And I was very excited. This changes what I'm going to do from here on out. I mean, phase ones are not that much money, but I think it was just the opportunities that it opened up, having that from the NIH and just my office, and it was great.
And the validation for yourself, yeah.
Yeah.
Well, congratulations again on that success. And I know we've chatted about a lot of the things that you've been working on, but I also like to talk to scientists about what they like to read and what they like to do with their time when they're outside of the lab. Angelique, what is on your bookshelf? And can you recommend a book to myself and our listeners that you've read and really enjoyed, whether it's a science book or a non-science book?
Let's see. Well, my favorite author is Stephen King. My dad loved him when we were younger. He read it and we read all of his books. And so I love Stephen King. I love the Dark Tower series. A lot of people say this, but this book really is actually very good. The Alchemist, like if anyone's ever in a period of their life and you're just, because I remember someone recommended, I just like kind of like in this gray zone period of life. And I was like, okay, let me just read this book. And it's definitely inspirational. And for people that are kind of feel like you're kind of lost and you're wandering a little bit, that's definitely a great book. But the book that I'm reading now, in all honesty, that I really love, it's nothing to do with science and nothing to do with science fiction. It's a book by Bell Hooks. She's an African-American feminist. And the book is called All About Love, New Vision. I love that book. For anybody that is interested in, I guess, the philosophical notions of love, not just like relationship love, but love of mankind and humans and things like that, I think it's a great book. Sometimes I just like to something that's totally not related to science at all and just related to humans and life. Because I think as scientists, we can become somewhat robotic, I think, at times with our goals. And so I would say that book by Bell Hooks is amazing. I love it. There's so many great quotes that can come out of it that can change the way we interact. And also, I think about it in terms of my company and the goals of my company. And ultimately, I want to make a difference in not just our bank account, but I want to make a difference, right? I want my technology to help somebody that is suffering from a health condition that otherwise would not be cured or aided. And that will kind of help me refocus, like, okay, what am I really doing this for? Not just the love of science, not just the love of money, but there's something greater to it, because money and science don't really motivate you when things aren't working out too well.
Sure. It's for the greater good, yes.
Yeah, for the greater good.
Well, Angelique, I think you've thrown out a recommendation for just about everybody's taste out there. So we will put Stephen King Dark Tower series out there, The Alchemist, and then also this last book you mentioned out on our website for our listeners to find if they are in search of inspiration or their next great read. And now, one thing that we haven't yet mentioned about your career in science are some of the opportunities to travel. And I think this is actually a pretty big part of the life of scientists, kind of no matter what field you end up in. So can you talk about one of these travel experiences of yours, one of the most memorable ones you've had, and tell us a little bit about where you were and why it was so memorable?
when you're a graduate student, traveling is like the greatest perk ever.
Right.
Like all these nice like international conferences and things. So I went to a lot of different places, and even post-graduation, I've been in a lot of different countries. But my favorite place that I traveled was a conference in Hong Kong. It was IEEE MEMS International Conference. And Hong Kong was great because it was just so different than anything I'd ever seen before and experienced up to that point. But then one of my good friends, she was Malaysian, and so she was going to go home to Malaysia. And she was like, "You should come with me to Malaysia." And I went with her to Malaysia, and her mom was just the best ever. Like, she was such a gracious host. It doesn't even define what she was. But she was literally giving me a tour of everything you could possibly eat and everything you could possibly see in the region that we were at. And that was really great because I think I saw a part of the world that was very different from terrain-wise from the United States, people-wise from the United States. Malaysia is also a very mixed culture area. You had all these different kind of flavors and sights and sounds from different regions of the world that were all kind of in that area. And I love tea. I got to go up to the Cameron Highlands, and it was just beautiful to see all these rolling hills of tea leaves, and it was just so serene, and I will never forget that trip ever. It was great.
It sounds amazing.
Wonderful.
I think you get a totally different experience too when you're able to travel with someone who's from the area or who has family in the area. It's like you're way off the beaten path, not just doing the touristy things.
Oh, yeah, definitely. And recently I got to go to Thailand. And again, I had a really great friend that she wasn't there, but she had hooked me up with her brother that was there. And he had shown us around Bangkok. And he was just, again, like an amazing. I always think like Americans don't do such a great job of showing people, I think, around that come from other countries. And when you go to another country, like people just have such pride in where they're from, and they just are such gracious hosts. They'll show you around everywhere and take you everywhere. And anyone ever comes here in the U.S., if they have a random friend that's in the U.S., I have to remember to do the same.
Yeah, build your itinerary now.
Yeah, we're like, well, here's the McDonald's over there.
Here's Starbucks. Yeah.
Here's a tourist map, I guess. And see you later. I'm not going to drive with you in New York City. I live here in Louisville, Kentucky. Like,
right.
Here's the train. Here's how you can take the train there if you want. But like when you go to other countries, people are like, okay, I'm going to get on this 3-hour like bus ride with you because we're going to go to this other city because you got to see this other city. And
yeah.
So it's always, like you said, it's great when you have somebody there that knows the area and that's from the area. And I don't like doing the tourist trap thing. So they're always good to say, like, yeah, you can go there and we can look from the outside, but don't waste your time going on the inside. I mean, if that's what you want to do, fine. But and I'm like, no, I don't want to do that. I want to do what you do.
Right. Well, these sound like wonderful trips, Angelique. It sounds like you had a great experience in both these places. And I think through science, you can go to visit so many cool places. And you snuck in there that you have a love of tea. I'm a tea enthusiast myself. What is your favorite kind, or did you have a particular kind in Malaysia that really stuck in your mind?
Malaysia has this, it was like Earl Grey tea, but it had tangerine flavoring to it too. And it's really faint. Like it didn't taste like tangerine,
Ooh.
But Earl Grey has already the orange oil.
The bergamot. Yeah,
bergamot, but it was like the tangerine instead. And that was my favorite one from Malaysia. And I love that one. I love with cream and honey. But I have maybe not a favorite tea, but when I was in Ann Arbor, they have something there called the tea house. If you're ever in Ann Arbor, go to the tea house. They have this wonderful wall of tea, but all the teas are very flavorful. And so my favorite thing to do was to go in and pick out a random smoky tea and then mix it with a fruity tea. And they would be like a tea mixologist. That's what I like. I go in there and I'm going to drink this random chili flavored tea. Yeah. And I'm going to put a black Irish tea with it or something like that. And so I really miss doing that.
Yeah. Well, I'm going to have to put that on my list of things to do in Michigan. So.
Yeah, you have to go there.
Well, wonderful to hear about these travel opportunities that you've had in your career. And I think you also get opportunities to work with some phenomenal people as a scientist. And I think we mentioned a few times in this interview, there are some stereotypes about what scientists are like, but I love breaking these stereotypes on our show because there are so many fun, funny, and phenomenal people in science. So can you share with us, Angelique, one of your own stories of this human side of science, or maybe a quirky tradition that sprung up, or just a fun or fond memory you've had with people?
I don't know if there's a particular quirky tradition. I'll tell you a meaningful tradition. So in my office in University of Louisville, I have this big Michigan flag, and we had a tradition as graduate students that when somebody graduated, defended their dissertation, that they would buy the big Michigan flag with the block letter N on it, and then everybody would sign it with like little messages and notes and things like that. And whether you were close to the person, you weren't close to the person, you would see people all the time in the hallways. And so I had that flag hanging up in my office, and of course it's Louisville, so.
Right.
They like to point out the fact that they beat us in the championship game, but all that aside, I think it's a great tradition. that the students do there, because sometimes I'll just be in the office and I'll look up and I'll read a message somebody had. And I'm like, who was talking about that? Oh, okay. They're telling me, like, be a queen. Like, okay, all right, I'm going to be a queen today and solve this problem.
Right.
So it's just random messages that I look up, and they're all kind of inspirational in certain ways. So I really like that tradition that the students, at least in the men's area, that they do at University of Michigan, because I think it has long-term inspirational impact. And then just scientists, like you said, scientists are quirky, weird people. I love that show, Silicon Valley, not as a scientist, but it reminds me a lot of my undergrad and perhaps my master course experience. Mm-hmm. People always say I'm an entrepreneur, I should love the show. I actually resonate with the show more so because I was a computer engineer and an electrical engineer. And I hate to say this, but the people on that show reflect every study group I ever had.
Really?
Yes, and I was talking to my friend, she's a physicist, and she was like, yes, I worked with those people. And there's something, in a way, very weird. There's something almost nostalgic, and like I miss those people, those random conversations, physicist conversations about just random things that you should not be equating to equations at all. And it's usually something lewd, being the only female in those groups. It was usually some lewd thing that they had gotten off sidetracked with, figuring out some mathematical way to do something that it was like, can we not be talking about this? But it's also kind of hilarious stuff. But let's see how far you guys are going to go. Are going to go with this. So I think that people are just very quirky in science, and I like that. I miss that. I think the older you get and the more you get into the established field, the less freedom people feel to be quirky, and everybody's trying to be a little bit more mature. And that's fine too. But I love it when I run across a scientist that just loves being themselves and is unashamed about that.
Absolutely. And I think there are so many different types of people in science. So you can see some really fun, quirky people, but in lots of different ways, and very creative people. So there's a mix of everybody, which is wonderful for our listeners out there to hear. There's no right picture of who a scientist should be.
Not at all. Not at all.
Absolutely. And thank you so much for sharing this tradition of your Michigan flag. I think this is wonderful to have this visual reminder of the support and encouragement of your colleagues with you for the rest of your career. So now we've talked a little bit about your research and some of the things that you're working on, but what I love to ask scientists about are the questions that they haven't been able to answer yet. So Angelique, I want to pick your brain today. So can you tell us, if I gave you everything today, if funding, staff, technology, feasibility, none of these normal barriers were a problem, what is the one question that you are just dying to know the answer to that you would want to tackle?
I can tell with lots of questions in my research area, and I've already written them down and earned grants. Mm-hmm. But if the thing that you could add to that is not just funding and staff and technology and feasibility, but if you could add to that freedom to investigate any scientific question that you wanted to investigate, period, like outside of expertise.
I like it.
I'd like to investigate, I guess what we consider spiritual world or whatever their belief system is, right? People say, do you believe in psychic ability? I don't believe everybody says they're psychic, right?
Right.
I'm Christian. I believe in God. I believe in Jesus. I'm spiritual on top of all of that. I think God works within science. And so I think that there is a whole level of scientific explanation for certain random things that we experience in life, or even just how does this medium here know that you wore a pink sweater when you were young? I think that could be just a spiritual level thing, or it could just be make-believe. Like, some people believe in it at all. I personally believe in it in certain aspects. But I think it would be interesting to know whether it's also, if there's a scientific foundation for it. Just like we don't see electrons because somebody figured it out, right? When they figured out that those electrons exist. And there's so many things aspects of science that are not visual, but we know because of mathematical equations, we know because of scientific methods that these things exist. If feasibility wasn't a concern, funding wasn't a concern, and I wasn't going to be looked at as a poop, I would love to know what, for lack of a better term, wavelength, although I hate that term because that's not wavelength is something totally different. Scientific construct that has very well-defined terms. Sure. But just in a colloquial sense, what are we missing in our whole system of how we interact, not just humans, but with animals as well, how they communicate. I'm very interested in pheromones. So I was looking at random journals on pheromones and stuff, and it just drove me that this thing that we control, especially with women, right, controls our interactions, our behavior, cycles and things, and we can't see it. And I think those things are not really discussed or researched very much for whatever reason, because they're not practical.
Mm-hmm. They're sort of taboo. Yeah, it's taboo. It's not practical, but I feel like there's a whole missed opportunity to fully understand our world scientifically that we just aren't tapping into because it's just written off as like, oh, okay, that's
it's either make-believe or it's all spirituality or it's not worth looking at. Who cares? So what? Your cycles align. Who cares? What does that mean in today's like?
Right. Well, Angelique, I love some of these questions you raised. And I think it's interesting to think about it in the context of history, right? Because so many things that we take for granted as obvious today were magical hundreds of years ago. Like no one understood them. No one believed in them. And I think hundreds of years from now, we'll be looking back and saying the same thing.
Oh, yeah, I think so.
Absolutely. Well, wonderful to hear these big questions that are stuck in your mind, Angelique. And I think so much fun to ponder them. We've talked a little bit about some of the people who you've encountered across your career who may have had a big impact on you. And one of the things that I love to provide our listeners with is some advice that might help them in their careers as they move forward. So Angelique, can you think back on all the advice that you've received from different people in your life and your career? And can you share with us the best piece of advice you think you've ever received?
I can't remember the best piece of advice I ever received. I don't think the things that I received most have been specific pieces of advice or more so ways of living. I learned from my mother to always be determined and to not give up, and that there's always a way to work it out somehow. And that way is not just like sitting back and waiting for like things to naturally work out, but like you have to be aggressive about trying to make things work out. I use that all the time, every day. Mm-hmm. Recently, though, if you want like a piece of advice that someone gave me like recently in the last few years, it was to focus. I don't think I'm alone. I think a lot of scientists and I know a lot of entrepreneurs have a hard time focusing. We think of an idea and then we're like, okay, this is great. We investigate it. And then another idea pops in our head. Before we know it, we're like writing another grant for something else.
Right. Shiny object syndrome.
Yeah. We're like, okay, let's do this. So somebody told me focus on one thing and do it really, really well and become an expert in that. And then once you've had that success in that one area, then the world is like your oyster. Then you can do whatever you want, basically. It's almost like your ticket to the show of life, almost. But you have to focus in one thing, and you have to be really, really good at that one thing, and you have to make some big impact in that one area. And then once you make that, then you can go and do whatever you want to do, a million things, because people will support what you've done because they believe in you. And people want to be a part of what you're doing because they know that you've been successful in something else. So I thought that would be my one piece of advice. Like when I see a student or anything like that, I'm like, okay, it's hard, but try as much as you can to focus on one thing and just do really, really well at that one thing. And I still struggle with that.
I do too.
So now I have systematic ways of getting around that. Like, okay.
Yeah. That is amazing advice, Angelique. I think both of these pieces, be determined, don't give up, and also just rein it in sometimes. Focus, get one big success under your belt sometimes, or be an expert in one specific area, and then you can branch out from there and do other things that you're excited about. So listeners, definitely take that to heart. And Angelique, is there any other last piece of advice or a last note of inspiration that you want to end our conversation on today?
People say this all the time, but I think it's worth saying again that try to block out all of the negativity that you get from people that, and it's not, people aren't intentionally negative, but people will not agree with what you're doing at any point in time, right? People will be lined around the corner to say what you're doing doesn't make any sense.
Right. You can't please everybody.
Yeah, you can't please everybody. But it goes back to that verse that I had said in the beginning. Write down your plan for life, for career, for your research, for your product, for whatever it is, for your company. Write it down clearly so that you can see it, and that's your vision. And when things start going hectic and start going crazy and it doesn't seem like it's working out, and it seems like everybody's saying like, okay, you're a loser or you're not doing well or whatever, just go back to what you wrote down and ask yourself, okay, does this still make sense to me? Yes, it still makes sense to me. Okay, then it's just on a delay. It's going to come through. Just be patient and keep working at it, and it'll come back to you. And that could be advice that will lead you maybe not to the vision in the tablet per se, but even if it doesn't lead you to exactly what your vision is on the tablet, it'll still lead you to a great place. Because as long as you're working really hard at something and you're working with conviction about something, in my eye, yes, you can't help but be a success. So that's my piece of inspiration to individuals.
I love it, Angelique. And I think writing it down then helps you focus, helps you really keep your mind on achieving that dream that you have. So fantastic advice for our listeners. Now, can you tell them how they can reach out to learn more about you or your work?
Sure. So I'm currently working on constructing my website. I never really thought I needed one. I had a concentrated customer base, but now people keep asking me, like, you have a website? Like, and I was like, okay, I guess I should have a website.
I should have that. Yeah.
I should have that. But how they can reach me, though, Angelique at MEMStim.com. That hopefully should be simple enough to remember, and they can send me an email, and I check my email quite frequently, so that should work.
Perfect. Well, listeners, definitely reach out if you have questions for Angelique. And Angelique, thank you so much for joining us today and sharing a piece of your story.
Yeah, no worries. I'm glad you had me on. I had fun.
Well, it was a pleasure to speak with you. And listeners, wonderful to have you here as well. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.